Hello, in this video we are going to present the Asset Discovery Tool, or ADT. First of all, it's important when we are managing the cybersecurity of an organization to have an image or faithful image of the network assets that can compromise our systems. These assets can have vulnerabilities that can compromise the cybersecurity of an organization. For this reason, the ADT is an important tool in managing the cybersecurity of a system or organization. So in this context, our ADT represents a set of novelties with respect to other solutions that we can see here, but I will explain later. First of all, I would like to show the main architecture. So the main architecture shows that we have three main elements in the ADT. One is the ADT main node, that is the main element that will receive all the information from all the different networks. We have the distributed nodes that allows to cope with network isolation, being executed one distributed node in one of the machines that are in this in these isolated networks. And also we have ADT REST API that is the one that allows this communication with other CUREX tools as well as the users. And this is important because all the information that will be gathered by the ADT will be available to other tools to help in improving the cybersecurity of an organization. So what are the main novelties that we have done in this ADT? Well, the first one is that we are able to discover the assets in two different ways. We have an active way when the network is scanned in regular intervals, and a passive where the DHCP packets are intercepted to detect new assets in real time. This is also something that works together with this enhancing of using the ADT in different networks, allowing to cope with the network isolation. So it is possible to deal with this problem using our technology. We have, on the other hand, the Trust Platform module, that it's a module that allows to improve the trustiness in the main node. Okay, so if we detect changes in the system hardware configuration, we will disable some of the ADT functionalities. We have also implemented an NLP service that allows to send text describing the networks in natural language, and on the other hand, we have also a natural language pattern module that allows to create reports with the information that has been gathered using natural language and providing PDFs with all the information of the assets discovered. We have also developed an ontology-based representation that allows to semantically store all the information in a Virtuoso triple store, and allows other users and tools to retrieve this information, as well as dealing, for example, with the idea of having different datasets that can be linked together using the semantic descriptions. And finally, we have developed a visualization system, a new visually catchy interface to monitor the networks in the ADT tool. So how it works? I will briefly show how it's working the ADT. The first, it's in the mode of passive or DHCP sniffing. The idea is that when a new device is connected to the network, we are able to see the different DHCP messages that are sent through the network, and allowing, for example, in this case, to detect that a new device has been connected, as we can see here that we have a new device with the IP 172. Etc. etc. On the other hand, we have the active scanning. In the active scanning, the ADT is going to to execute regularly or periodically a scanning process in background, and it's going to detect the assets that are in the network, new assets or all assets. The idea is that with this information, with this discovery, what we are going to produce is this type of information. That this is a JSON file, example of the JSON file that we produce, that we can see here, for example, how we have in a given node IP address that represents the network or subnetwork. We have two devices with two different IP addresses, and also we are able to discover the ports open, the services running, as well as the operating system when this information is available. This is basically mapped to a table that looks like this, and it's indeed the input to other tools, like in this case the VDM. So this is basically the input and the output of the ADT. In the next video, we are going to show how the ADT is working in general and showing all the functionalities. Thank you.
Hello everyone, and welcome to a demonstration of the functionality of the Asset Discovery Tool, or ADT, from the CUREX project. From the main node directory, and after having configured the necessary environment variables in the .env file, we can now launch the main node with the ADT services script. When it's done, the traces will show the URL through which the administration website is accessible. From the administration website, one can see a table containing all of the available credentials. This button that you see here indicates the status of the Trusted Platform module, or TPM. Although in this case it is disabled because this machine doesn't have one, when it is available, it guarantees that the system hasn't suffered any modification that puts the integrity of the system under some sort of risk. These credentials have been created for this video demonstration, but if we wanted to add a new one, we could do so through the New Credentials tab. It will show a two-step formulary that we need to fill. Now, the distributed nodes that we are going to set to scan are part of the system's distributed architecture and imply a major innovation with respect to existing systems, as it deals with network isolation. To set a distributed node to scan, we first need to copy the credentials associated to its configuration. From the distributed node directory, we will provide this token as an argument for the deployment.sh script, remembering to fill all of the other mandatory arguments as explained in the user manual. The logs of the distributed node are now being shown, and we can leave this execution running for as long as we require. After having had the distributed node scanning for several iterations, we are now going to use Postman to see what the main node has stored so far. It is first necessary that our administrator has enabled a token for querying the endpoints associated to the retrieval of scanning information. So, our first query will be to the /VLANs endpoint, which provides summarizes information about each of the snapshots generated by the scanning process. As it can be seen, the nodes defining the website are present here and contain information about their associated snapshots. This information, it would be interesting to know what is inside each of these snapshots. So, to provide an example, we are going to query the information inside this snapshot, for example. We first copy the snapshot ID field, and we will use it as a parameter for the /VLANs snapshot ID endpoint. Now, this endpoint provides us with more fine-grained detail about this snapshot, including its devices and the corresponding ports and services running in it. Another important source of information are snapshot changes, which are items containing only the information that is detected to be new or modified between snapshots. We will query this data through the BDM's endpoint. As we can see, the format is different from the snapshot that we have just seen, and indicate the value for specific fields, meaning that it has changed in comparison to the previous snapshot. When a field hasn't changed, it contains the value no change, as we can see here. An important feature of the ADT application is its capability to detect new IP assignations in real time by sniffing the DHCP traffic on a given network. With an ongoing scanning process in this VLAN, connecting a new machine will make the parallel DHCP process detect it, and it will generate a snapshot that will instantaneously be sent to the main node. This capacity to make real-time detection of changes and provide other systems like the BDM with the associated information allows for a faster detection of vulnerabilities, as it does not depend on periodical scans. To demonstrate this functioning, we are going to deploy a Windows machine on this VLAN using this script. By now, with the machine finally up, the DHCP service should have detected it and started its processing independently. Let's first look up the details of this machine to see what we expect to find when querying for the corresponding snapshot. If we look at the distributed nodes logs, we can see that the detection did in fact take place. We are now going to use Postman to look for the snapshot of this system again and hopefully find the new DHCP one we just processed. As you can see, here is a snapshot which discovery method field contains DHCP. So we can now use this snapshot ID in the /VLANs snapshot ID endpoint to see its details. And we see how they match with the details we saw in the Windows machine. One of the multiple ways in which the ADT allows to inspect its stored information is by querying the Virtuoso database through this web interface. Virtuoso allows for a semantic storage of the information, and it enables the interoperability between systems with defined semantic vocabularies, as well as federated queries to other datasets. So, by typing a basic query and selecting the desired format for the output, for example, Turtle, we can click Send Query to get a file. We can now check our downloads folder to see the output. Another way this application offers information about the conducted scans is by means of the visualization module, accessible through the administration website. This graph shows each of the scanned networks and its discovered devices as nested circumferences, and one can click on them to access an instantaneous summary of each device's ports and its running services. Another way of obtaining scanning information in a straightforward manner is provided by the PDF reports module, accessible through the administration website. In it, we access a new view in which a table is displayed, which contains a list of all collected snapshots, specifying the node that identifies them as well as the date in which they were received. So, suppose we were interested in the snapshot that I'm marking right now. We can click Download to obtain a PDF report. And now we can go to our Downloads folder to see its details. ADT also provides a functionality to process natural language inputs about a specific VLAN. To do so, one can use the /NLP endpoint with a valid token generated by the administrator and place the input text as part of the query's body. After the successful processing of the input, the snapshot object stored in the main node is prompted as output. So we can now go to the /VLANs endpoint to look for the snapshots of this machine again. We can see how there is a snapshot which discovery method field contains NLP. Its details are accessible via the /VLANs snapshot ID endpoint in the same manner as in the previously shown cases.